So let us simply go to the formation of energy bands. Okay, is it visible to all?
Yes, ma'am.
Okay, take care. Now I told you that if we draw the band structure of, say, we draw the band structure of metals, we draw the band structure of, for example, some insulators. Metals, let us broadly say conductors. Let us not say metals because there are many of the non-metallic materials which are also conductors. Okay, conductors, insulators, and semiconductors. So I will very quickly draw the diagram like okay, this. So if this is the energy level E in electron volts, then obviously this is your, for example, valence band. Your valence band and your conduction band starts from here. So you can say that conduction band starts from here and goes up till here, whereas the valence band starts from some low level and goes up to this level. Okay, so you can see this portion of the valence band and the conduction band which are overlapping with each other. So you have overlapping valence band and conduction band. Now valence band is always filled with electrons. So this means when the valence band is filled with electrons, because of this overlap between the valence band and the conduction band, there are always electrons present in the conduction band. Okay, is it okay? Because of the overlap.
Yes, ma'am.
Okay, now next if we go to, let me rub it off, diagram badi ho gayi. If we draw similarly the diagram, energy band diagram for the, and one more point is here that no there is no band gap. Band gap is the distance between the valence band and the conduction band. Now for the insulators, again the y-axis is the energy, electron energy in the electron volts. Then here you have conduction band, start of the conduction band, that is the edge. Edge को label करते हैं EC से. And below here you have valence band starting from some low level going up to this level. The top level is determined by, is denoted by a symbol E subscript V, that is the top, that is the energy of the valence band, but it is the top energy of the valence band. EC is the bottom energy of the conduction band. You can similarly use these notations for the metals also. So for example, this top will be EV and this will be EC. So you can see EC and EV will be like kind of overlapping. Okay, and the distance between the conduction band and the valence band is the band gap. It is denoted by the symbol E subscript G. Okay, now in the insulators and semiconductors, this EG is very large. EG is very large. So conduction band is empty and valence band is always filled with electrons. But these electrons, these electrons need to be given very large amount of energy so that they can go to the conduction band, and that amount of energy, for example in volts, like 10 volts or 12 volts or 6 volts or something like that, depending upon the band gap, cannot be supplied. Okay, so we say largely we say that at even at the room temperatures, insulators are the bad conductors of the electricity. Okay, now third is the semiconductors. Now semiconductors, again the vertical line represents, it's not a straight line, representing like this. Let us say this is the bottom of the conduction band EC. Let us say this is the top of the valence band EV. And what is this? This is EG band gap. Now I'll be referring to EV, EC and EG, and this is the energy, electron energy, and the units are electron volts. Okay, this is the valence band. Here you have the conduction band. Again, for the semiconductors at temperature T equals to 0 degrees Celsius, all electrons are in the valence band. So no electron is in the conduction band because there is a band gap between the two. So at T equals to 0, semiconductors behave as insulators. But when temperature is, for example, 25 degrees Celsius to 30 degrees Celsius, that is room temperature, then electrons in valence band go to conduction band. So there are some electrons here, they gain some energy and they go to the conduction band like this. And here they become free electrons. So here they become free electrons. Now when the electron leaves the valence band and goes to the conduction band, what is left behind at the place where the electron was in the valence band?
Hole.
Holes are left behind. So holes are left in valence band for every electron going into where? Conduction band. Okay, going into conduction band. Now why we say that at room temperature electrons in the valence band go to conduction band and holes are left behind? Because at temperature T equals to 25 degrees Celsius to 30 degrees Celsius, whatever may be the range, electrons जो valence band में होते हैं, electrons gain thermal energy. Very important point. Electrons gain thermal energy, which is given by Vt, and the expression for Vt is Vt, that is the energy, is K T temperature divided by Q, where K is the Boltzmann's constant, and T is the temperature, and Q is the charge of the electron. Okay, charge of electron. Okay, so when you substitute the value of the Boltzmann's constant, what is the value of the Boltzmann's constant? 1.38 into 10 to the power of minus. Anybody? What is the value of the Boltzmann's constant? आपने बेसिक इलेक्ट्रॉनिक्स में भी पढ़ा होगा. Just recall. Recall. बताओ. Yes? So you need to remember these, constants, units and other things I told you earlier. K value is 1.38 into 10 to the power of minus 23 joules per Kelvin. तो ये कांस्टेंट्स आप याद रखेंगे. 1.38 into 10 to the power of minus 23 joule per Kelvin. Q is the charge, electronic charge, and T is the temperature. Temperature is your choice, like whether you keep it as 25, whether you keep it as 30. But remember that here the scale is Celsius scale, and if you are using the Kelvin scale, so it's better that you convert centigrade into the Kelvin. ठीक है. कैसे करते हैं? प्लस 273 ऐड करते हैं जो भी सेल्सियस में टेम्परेचर. फॉर एग्जांपल अगर मुझे इसको कन्वर्ट करना है, इफ आई हैव टेम्परेचर T इक्वल्स टू 25 डिग्री सेल्सियस, इन केल्विन इट विल बी 25 प्लस 273, सो दैट विल बी इक्वल इनटू 298 Kelvin. Okay, fine.
Yes, ma'am.
Okay. So these things you want to know. So the Vt value comes out to be equal to, for these values, it comes out to be equal to 26 millivolts or 0.0259 volts. You need to remember. So this is the energy which these electrons require, and they so that they go to the conduction band. Now, this is any questions till now? Any questions?
No, ma'am.
Any questions? Other people? अच्छा ठीक है. Now when we are drawing these band diagrams, we can see that we are drawing some kind of vertical lines like these. And valence band के लिए we draw a horizontal line, conduction band के लिए we draw a horizontal line and something like that. But now we need to see कि how these bands are actually formed. So जो मैंने आप लोगों को पहले दी हुई थी PDF I had shared with you, where the theory of the one electron atom was shared. So what is it actually? It is simply that if you have a hydrogen atom, it has a nucleus, okay, and since the electronic configuration of the hydrogen is 1, hydrogen is atomic number is 1, so the electronic configuration will be 1s1. So this means that surrounding the nucleus there is a shell, one shell only, where you have one electron, okay, where there's only one electron. This electron does not appear as a, the electron does not appear to us as a ball or as a pointed kind of object which we draw, but rather it ये कौन गाने सुन रहा है? ये कौन गाने सुन रहा है? Turn on your mics, all of you. किसकी इससे आवाज आ रही थी? Otherwise I'll leave the class.
मैम ये वाइब्रेट हो रहा था किसी का.
नहीं गाने की आवाज भी आ रही थी ना. कहाँ से आ रही थी बताओ?
सॉरी मैम, मेरे से नहीं आ रही.
किसकी इससे आ रही थी?
मैं फोन आया था, फोन कॉल आई थी.
किसको आई थी?
मैम मुझे.
अच्छा ओके. तो ये जो इलेक्ट्रॉन है, ये इलेक्ट्रॉन यहाँ पर है, ओके. Now this electron, one electron atom, what does it say? It says that this electron around the nucleus, it appears like a what? What does it appear like? ये जो हमने देखा था ना, ये अगर हम इसका probability density function दिखाएंगे ना, because electron is denoted by psi. Okay, so psi is the wave function, but psi does not have a physical significance. So what has a physical significance? Psi into psi star. Okay, that is equivalent to psi square. Okay, so psi square is actually a probability density function, so it appears somewhat like an electron cloud. So this appears like an electron cloud. So what is an electron cloud? It's like kind of, a space of charge. Charge can be positive, charge can be negative, but when it is electron, obviously it is negative. And you know that around the nucleus there are only electrons revolving. Okay, where are these protons? Protons are in the nucleus. What is nucleus made up of? Nucleus is made up of protons plus neutrons. Okay, neutrons are neutral, protons are positive, electrons are negative. Number of protons is equal to number of the electrons, so that is why the atom is electrically stable. Otherwise everything would collapse. अगर इसमें imbalance हो जाएगा, वो भी मैंने परसों elaborate किया था कि it will collapse. Now the thing is that, for example, now here we have one atom of hydrogen. Now suppose we have two atoms of hydrogen. Suppose we have two atoms of hydrogen. What is going to happen? One atom here, like this. This is the electron, this is the neutron, this is hydrogen, say H1. And let us say that this, with the electron, another electron here, this is hydrogen, second hydrogen atom, okay. H1 or H2, okay, this is one, this is a, and let us suppose the distance between the two is some r, okay. अब इसमें जो ये इलेक्ट्रॉन है, इलेक्ट्रॉन क्लाउड है यहाँ पे, इलेक्ट्रॉन क्लाउड है यहाँ पे, ठीक है. क्लाउड मीन्स एक स्पेस फिल्ड विद सम चार्ज, ठीक है, जहाँ पे वी कैन फील दैट देयर इज द प्रेजेंस ऑफ द चार्ज. ओके, सो क्लाउड मीन्स वी आर नॉट सर्टेन about the exact position of the electron. Now, if the distance between this hydrogen atom and the second hydrogen atom, that means let us say this is first hydrogen atom, this is second hydrogen atom, is very large. Okay, if this is very large, then this atom is independent, this atom is independent. Now, when the distance between the two atoms starts to decrease like this, okay, I'll rub it off here. Okay, okay, when it starts to decrease here, let us say like this again. Okay, now what will happen here? There will be some kind of forces of interaction between them. Still, this will have its own shell and this will have its own shell. Now, if r keeps on decreasing, which is the distance, if r keeps on decreasing and they reach to a point where it is like this. So, can you now tell me कि ये कितना close आ गए हैं, है ना? They have come close to one another so that there is some kind of interaction. So there is an exchange of energy between the outer shells. Okay? There is the exchange of energy between the outer shells. Further, when they come more close, like this, the nuclei of the two also start to interact, the electrons start to interact, and what happens is like this. If this is the distance, this is the energy levels. When distance was, we are measuring distance 0 to some positive value from here. When the distance was large, each of the this atom was having its own energy level. One moment. Yeah. So each of the atom was having its own energy level like this. Okay. They were having their own energy level, and now when they have come close to one another, what is happening? There is the interaction of the energy between the two, and you can say that now this we can say that first they were separate, and now when the distance has decreased, they have now become single like this. This is a single level where two electrons are interacting with one another. First there was one electron here, one electron was here. For one atom. When they have come closer to each other, these outer energy levels are interacting with one another, and what is happening? The two electrons which are here, they are interacting with one another, and the resultant molecule is H2. Okay?
Yes, ma'am.
Yes.
Any problem?
No.
Okay. This is the example with the hydrogen. Now let us come to the silicon. Silicon has an atomic number of 14. So can you just write its electronic configuration? 1s2, 2s2, 2p6, and 3s2 and 3p2. Okay, so that is 1s2 like this, then 2s2, 2p6, these are the electrons, and then 3 is like this, 3s2 and 3p2. What is it like? This. Okay, 3s2 or 3p2. Now how many levels are filled and how many are empty? Is it a stable configuration? Is the last orbital filled or empty? Empty?
empty, ma'am.
It's not completely empty. It has 2 electrons. It is in order to achieve the stable configuration, it is short of 4 electrons. है ना? 1, 2, 3 and 4. So अगर if it gets 4 electrons, it will complete its octet. Right?
Yes, ma'am.
Okay. It will complete the octet. So okay. ठीक है. अभी can you draw a silicon atom like this in terms of the shells and the subshells? Can you draw? Try to draw. Try to draw. We can very easily draw it like, for example, here we draw on the nucleus. Nucleus can how many shells will it have? 1, 2 and 3. So it will be 1, then it will be 2 like this, and then it will be 3. Why only 3? Because these are the orbitals, these are the subshells which lie within the shell. Okay, so it will be like K, L, M and N. Okay, so here you will have 2 electrons which are very close, like 2 electrons here, then 2s2 and 2p2. So 2s2 2s2 के 2, 2p के कितने 6 होंगे. Okay, so it will be 1s2. This will be 2s2 and 2p6. Okay, internal. And then you have 3s2 and 3p2. So 3s2 will be here, and let us say 3p2 will be here. 3p2. Now how many are devoid? It is like you have 4 seats. One seat is here, another seat is here, one seat is here, another seat is here. Okay. इलेक्ट्रॉन तभी किसी एटम में शेयर हो सकता है, कोवलेंट बॉन्ड फॉर्मेशन की जो थियरी आपने की होगी वो तब हो सकती है when there is a room for the electron or the space for the electron to sit in. Now consider or imagine another silicon atom which is very nearby, like same case कि पहले वो बहुत दूर है. प्लीज ये वाइब्रेशन बंद करो जिसका भी फोन आ रहा है. सो सेम केस, जैसे कि ये हाइड्रोजन एटम्स पहले काफी दूर थे और अब ये नजदीक आ गए. सो वील कंसिडर द सिनेरियो फॉर दैट वेरी सिलिकॉन एटम व्हिच आर वेरी क्लोज टू वन अनदर, already very close. So like this, let us say this is the outer shell, let us say this is the inner shell, let us say this is the another inner shell, and let us say this is the nucleus. So again यहाँ पे यही scenario है. There are 4 seats vacant for the electron. There are 4 electrons in 3p2. There are 2 electrons in 3s2. Then similarly 2s2 and 2p 6 के भी होंगे और 1s2 के भी होंगे. So again this is one silicon atom and this is another silicon atom. So when they are interacting, or when the distance, that is the r is the distance. So when the distance between the two is reducing, they're coming closer to one another, what is happening? The outer energy level is interacting with the outer energy level. Only those energy levels can interact which have the same energy, which are at the same energy level. Outer cannot interact with the inner and form a shell. No, it's outer will be the second shell with the second shell, the third shell with the third shell. So this third shell will interact with this third. What is this interact? Exchange of energy. Then this second shell will interact with which shell? Second, 2 and 2, 3 and 3, and then 1 and 1. Okay, right. Now similar levels पे जिस तरीके से हमने ये किया, क्या ये वाला H2 का बनाया, उसी तरह से we'll see it for the silicon. Okay, now see, let us draw the diagram like this. Let us say this is the electron energy E and this is the distance between the atoms like this. Now when the distance is quite large, each of the silicon atom is behaving independently. Silicon के अपने levels है, इसके अपने levels है, so they are behaving independently like this. Single level. हर एक की अपनी अपनी energy level है. But now when they are coming closer to one another, they are interacting with each other and this single level is splitting. It is splitting into a band of energy levels. Now, let us take the case of the silicon. In the outermost shell, how many how many these how many levels are present? How many orbitals are present? Good, batao. 1, 2, 3, and 4. 4 orbitals, and 4 orbitals can occupy how many electrons?
8, ma'am.
8. Okay. So it is like, okay, 8. So it will be, let us say N. Capital N is the number of electrons. Okay. Capital N is the number of electrons. So how many levels are they occupying? They're occupying 4n. 4n levels are occupied. And how many levels are empty? How many levels are empty in the outer shell?
2.
2. No, levels. In terms of n. N is the number of electrons.
4.
4. So 4n are empty. Outer shell mein, what is the total number of levels? No, total. In the outer shell. Outer shell mein, what is the total number? Total. Empty plus occupied.
8, ma'am.
8. 8n. 8n is the total number of levels, energy levels. Yeah, electron levels. Energy levels which the electrons can occupy. So, when these atoms are coming closer to one another, this single band is splitting into 8n energy levels. Okay? So, that is something like 1, 2, 3, 4, 5, 6, 7 and 8. Okay. Okay? Separate, discrete levels. So, these levels are actually 8n. Okay? So, it is splitting now. Further, when the distance is reducing further between the two silicon atoms, what is happening? जो ये filled है, filled and unfilled है, the filled and the unfilled energy levels are again interacting with one another, and the result is that there is a splitting of these these energy levels in the outermost shell as splitting like this. See, the lower levels 1, 2, 3 and let me use another pen. ये बहुत important question है. See, I'll use this ताकि आपको ग्रीन से बनाती हूँ. ठीक है, यहाँ पे 1, 2, 3, 4, 5, 6, 7 और 8. ठीक है, 8. Further interacting, I told you that they'll separate 1, 2, 3 and 4. And here 1, 2, 3 and 4. Okay?
Yes, ma'am.
Fine. So, okay, so जो ये हमने रब किया हम उसको वापस ठीक कर लेते हैं ऐसे और ऐसे. ठीक है. Okay, so these are 8n and the lower levels here are 4n and the top levels are 4n, but the lower levels are 4n filled levels and the upper levels are 4n empty levels. And Can you see a curvature like empty gap between the two? You know? Can you see a curve like gap? This gap is Eg. This gap is Eg. What is Eg?
Energy gap, ma'am.
Yes, band gap. So this is how the band formation takes place. Okay?
Yes, ma'am.
देखो अब आपको क्या अंडरस्टैंड करने की जरूरत है. This I have shown you only for two atoms interacting with each other, but when we talk of a crystal may you do not have only two silicon atoms. Crystal is not made up of only two silicon atoms. Crystal is made up of how many number of silicon atoms? It is made up of n number of silicon atoms, where n is the Avogadro's number, that is 6.023 into 10 to the power of 23 atoms of silicon. So you can imagine that this silicon atom will be interacting with the neighboring silicon atoms in three-dimensional space. मतलब यहाँ से भी silicon होगा, ऊपर भी होगा, यहाँ से भी होगा, और top down, left, right, okay, above, below, everywhere there will be only silicon. So in that very case, what will be the number of levels? Here it will be 8n. If n is the number of the electrons and the total number of atoms is, say for example, nt, let us say nt, so it will be 8n multiplied by nt, है ना? 8n multiplied by nt, fine, for a silicon crystal. And further these 8n which are in the outer shell, ये आगे होके 4n nt filled बनाएंगे, 4n nt empty बनाएंगे. Now see, अब आप बोलोगे कि मैम ये 2 वाला जो स्पेस था या जो ये 1 वाला था वो चेंज क्यों नहीं हुआ? बिकॉज कि एटम की टेंडेंसी है कि जहाँ पे जो लेवल अनफिल्ड होगी ये उसको फिल करने की कोशिश करता है. एवरी एटम हैज अ टेंडेंसी टू achieve the inert configuration with its neighboring atoms through the covalent bond formation. Okay, fine. So this is like kind of the sharing of the electrons, and then it splits. So 4n are filled, 4n are empty. So this is how the bands are formed. Fine, this is how the bands are formed. And further beyond this, in tomorrow's lecture we will now take up the Kronig-Penney model, which will tell you that how the Kronig-Penney model is going to tell us that how graphically the bands are formed. How no, I cannot say exactly graphically is the result. We can say that analytical modeling and graphical solution. Analytical modeling and graphical solution for formation of bands in semiconductors. Okay, so that is done by what? That is done by the Kronig-Penney model. So that is what is explained in Kronig-Penney model. Okay, so any questions, please tell me here only. Any questions, any doubts related to what we did today or what we did in the previous lectures, kindly let me know now. Okay, no? I'll be sharing the PDF and I'll be uploading the lecture on my YouTube channel. So अगर किसी को कोई डाउट होगा आप वहाँ से देख लीजिएगा. Okay?
जी मैम.
Fine. Just a moment. I'll stop the video.